So when we can use multiple regression, first one is when we want to predict something. So using the past data, so we are trying to predict something new information. So this is quite common. When the new customer coming in, then by looking at gender of the customer, the age of customer, and their income of customer, they have a how big house, married or not, how many children they have, what kind of car he has. That kind of using that information, can you tell he will purchase our product or not? That kind of prediction can be possible if you just using all the past data, and you can do some kind of regression, and then using the regression you can just plug into all the x1, x2, x3, the variable, and then you can tell how much he gonna purchase our product or not. So when that kind of you wanna make that kind of prediction, we can use regression. Effective market. Effective market is when you trying to find out the sufficient statistics. Sufficient statistics is the statistic, the number that is enough to know something. So here, if this is true, I'm trying to find out y, but this is all my variable. But if I use only w, still I can find the y. Expected y is same. I don't need to know everything. I just need to w. Then I can find the expected value of y. Then what we call y is a sufficient statistics. Right? And then yeah, using the regression we can find is it sufficient statistics or not. Another scenario is the trade-off. When we talk about the salary and the pension, so actually the pension is when you retire, then you can get some money from them, right? And that's a kind of benefit of the job. When you got a job, you will get a salary, and then you also will get a pension. So we want to know how the people consider the pension compared to the salary. If you reduce your salary like $10, then your pension increase by $10, then people will consider it's the same thing or not. So if you do the regression using the pension and salary, right? And then if the beta 1 is -1, if this is -1, if pension increase by 1, salary decrease by 1, which means if we have you consider the pension and salary exactly the same thing. So if your salary goes down $10, pension goes up $10, then you consider that's the same. That's what you can find. How can people consider salary versus the pension? If you calculate this coefficient, you can tell somehow. However, if this is a 0.5, pension $1 increase, salary decreased by only 0.5, which means people consider the pension is like half of the salary. So I prefer the salary increase $1 rather than the pension increase $1. But how much? Yeah, still the high pension is better. So how much would you sacrifice the salary for the $1 pension up? If your pension goes up $1, then how much you can sacrifice your salary is a 0.5. So you consider the salary and pension in this relationship. So when you're trying to find out this trade-off between two variables, you can utilize regression. Regression is not only for the prediction at all. And this is also Sutry's the Paribus effect. So in this example is like that. Is it the white people? Yeah. still the, you know, people believe that there is some white people and black people, colored people, there is some kind of discrimination exists. So if you really want to know, there is white people get a higher wage um, if they have all same, I mean, the same education, same background, same experience, same ability, and so on. So you can just plug in that was in the kind of the factor, and if this B0 is a 0 or almost 0, then we can tell, yeah, there is no difference between white and then colored people in wage. But if this beta one is the big number, significant number, then we can tell, yeah, white people's wage is uh, different, on average is different than other colored people. Potential outcome and treatment effect. This is the usually we cannot find out. When we try to find out, you do the something and then you want to know the treatment effect. Then you have to have a very controlled set. So drug cases, so we can do the experiment, right? So we collected the patient, similar average of age should be similar, similar ratio of the man and woman, and then one group we do the treatment and the other group we don't, and then we compare the what is the effect. However, in a lot of social study, you cannot do that actual experiment. So you can just collect the data from past record, and then you're trying to find out. The problem is if there is a certain things. So here the example is like here. Let's say Y is the earning, how much the earning you can have, and then job training program. So if we do the job training program, I want to find out actually job training program will increase the earning. What is the effect of this job training program? And then the problem may have is like this. If the only the low income people participate in the job training program, right? It's possible. Someone who are earning a lot of money, then I don't need the job training program. But low earning people, they wanna have increase their earning, so they participate in the job training program. So if we don't include all other things, so if I can do the controlled experiment, I can do the similar, right? Similar education, similar ability, similar salary, and then one group I give a job training and the other group I don't give a job training. Yeah, we can do the random assignment. However, if we just collected the data from the society, it is possible only the low, less education, less experience, less ability people, most of the case, they just participate in the job training program. Then we cannot actually see what is the effect of job training program, because if that is the case, when you have a job training program, actually your earning goes down, because most of the people who earn a lot don't participate in the job training program. So effect comes out like a job training program will lower the earning. But can I take it out to the all other factor, education factor, experience factor, or other things? Then we should include this or other factor here in regression. Actually, by adding that factor, we are taking out all the effect of the education and so on. And then we can see the only job training program. So I will do this one, job training 98. Here, yeah, I will bring data job train 98 package equals would reach. Yeah, now we have a job training, right? And then we can do the JTrain. Oh, so I can detach client and then attach JTrain. Okay, and then we're gonna do the job training, regression, and linear model, and then we have to see what kind of variable we have. Is a train or not, and earning. We will use on 98. So on 98 is a part of the training. And you can do the regression. And then summary of the job training. Then you can see the training coefficient is minus 2.0, which means you have a train, higher training. I don't know, this train has a train is a 0 or 1. So if you have a train, your earning goes down, right? That's what's minus. If you have a train, your earning goes down by 2. However, if we add train plus, what else we have? What else variable we have? Age, education, married, okay? Age, education, married. Then if you do the regression, and then what you can see is this is still negative. I can add on 96. Yeah, so it depends. Yeah, if I do the like age, education, married, is still negative. However, if I include the earn 96, then now training has a positive. So this means is like before the training, what was their earning? If you take it out, then the training effect is positive. So now if you take a training, then you get a higher earning in the later. This is a prior earning level. So previously you earn little more, then yeah, you will earn little more later. If that's positive. If you married, you will earn more. If you are older, your salary goes down and so on, but training has a positive. So when you can use this regression, when you separate out of the other effect, actually by random assignment, you should be get rid of all the other effect, but that's under the controlled experiment. But most of case you cannot do the controlled experiment. You have to collect the data from the real world, right? In that case, how can I take it out or other factor, and can I get only the train some specific treat effect? Then you should use a regression and then apply all the factor. You can take it out the effect of other factors, so that you can find only the interested factor. What will be the effect of that? Okay, that's it.